Hello guys, this is Rachel from 3rd CSE and today I'm going to be explaining my 5th exercise in compiler design, system software and compiler design lab. So the fifth exercise for me is to simulate the deterministic finite automata. So it's simulation of DFA. So this is the code which I have for DFA, but I'll start off with explaining what DFA actually is. So a deterministic finite automata is also known as a deterministic finite acceptor, and a deterministic finite state machine is a finite state machine that accepts and rejects strings of symbols, only produces a unique computation. So as we have learned in deterministic finite automata, like the input, like all the states will have every state will have transition with every alphabet only once. It cannot have, if say there is a state like 1 and there are two alphabets A and B can have transition from one to any other state only once. It will not have alphabets like transition more than one, so it produces a unique kind of string. So this is basically deterministic finite automata, and so I'll describe this code first. I'll explain this code. So here what I've done is, like, for the transition table I've created an array here, and then I've initialized the alphabet set, the state set, and so on. So when I build the DFA for that, the input is read using the buffer reader, and BR is the object which is created by buffer reader. And first what I'm going to do is, like, I'm going to enter the number of alphabets in the alphabet set of DFA. So I'll run it and I'll explain it side by side. So first what I've got to do is, like, I have to enter the alphabet set, number of alphabet sets in the set of DFA. So number of alphabets, I'm just going to give 2 because I'm just going to use 2 alphabets here, A and B. So what the next point is like, whatever alphabet I enter, it will get stored in the alphabet set. It will be converted into an integer. It will get stored into the variable alphabet set. And the next one is to enter the number of states in the set of DFA. So here I'm going to enter the number of states as 4. Okay, so the next that will get stored in the states set, and the next one is to enter all the alphabets which are being used. So there are 2 alphabets I'm going to use, A and B, and next is okay. So that will be created. That will be the alphabets which are entered. It will be sent into an array list, and it will be stored in the alphabet. And here, as you can see, at the index position when 0 comes, A will be stored there, and in position 1 B will get stored. So what I'm going to do is, next is going to be the row transition. So for that row transition, I'm the row transition is nothing but just creating a 2-dimensional table where you mention, like, if the alphabet A comes and in the state 1, where should the transition go, which state should the next transition lead to. So I'm going to enter the row transitions. So as you can see here, what happens is, like, I'll enter the values of the transition table into this transition array which we created initially. So first row's transition is going to be 2 and 1. The second row's transition is going to be, like, when first state A comes, it goes to the state 2. When first state B comes, it goes to state 1. So next is going to be when second state A comes, it goes to state 2 itself. And when second state B comes, it goes to, just a minute, when second state B comes, it goes to state 3. When third state A comes, it goes to state 2. When third state B comes, it goes to state 3. And when fourth state A comes, it goes to state 2. And later when B comes, it goes to state 4, and again so after I've entered the values here, what happens is, like, it lasts the final state of that particular DFA. So that brings us here. So we're just going to create final state, and we are just going to enter the final state value. We'll get it from the user and we'll enter it into the final state variable. And so what happens is, like, it will print the final state. So I'm going to enter the final state here as 4, and here for stopping the input I have to give -2. So this is the code here. So what happens is, like, I'll add the when into, which is a variable which is not equal to 2, then I'll be adding the final state. If I add the final state 4 here, that will be given to the final state here, and then it will be stored into the integer value. So what happens is, like, once I enter -2, the entire input feeding will stop. So after entering the final state, I'm just going to give -2, which means the entire feeding will start, and I have to now enter the starting state. So for the starting state, I'm just going to give it as 1. Yeah, I'm just going to enter the starting state as 1. So after that, what is asked is, like, to enter your input with the character. So they're just asking us to enter the augmented string. So my input is going to be AABB hash. Okay, so this is the string which I'm going to be entering, and what happens next is, like, in this testing part, the input will be read into a string called input. So at the index position 0, initially I'll get A, and as you can see here, the input, the character at the index position, when it is, that is in the 0th position, when we don't have hash, it means that some string is going to be entered. And then what happens is, I'll store the character 1, and that will be stored in the index position 1, and so when I get one alphabet A, it will move on to the next state. That's why state -1 is done here, and I have to increment the index value. This will keep on happening as long as I get hash. Once I get hash, it means the input is over, like, you cannot add any more input to it. So what happens after this is, as you can see, the final state after giving the input is whatever state, and then your input string has been accepted by DFA. So when after giving all the input value, if my final string reaches the position 4, because 4 I already assigned it as the final state, if it reaches 4, it means that the input string has been accepted by my DFA, or if it does not reach 4, then it has been rejected by my DFA. So this is another example which I did, and here the string I'm going to be giving it as AB, and so on. So what went wrong is, like, my string, my starting will be A and ending will be B, but after B I will not be able to receive any A. So when A comes, my final state becomes 3, and in this condition, the input string has been rejected by the DFA. But as you can see here, when the input I have given is in this in the previous input that I showed you guys, when the number of alphabets in the set, I'm going to give it as 2, number of states 4, enter the alphabets A and B, enter the row entries of the transition table. The first row is going to have 2 and 1, second row is going to have 2 and 3, third row is going to have 2 and 4, fourth row is going to have 2 and 1. So here, if you can see, my input starts with A, it ends with B, but after B I'm not getting any more A or B. So A. So final state has been proved as 4, and that's my string has been accepted by the DFA. So this is how the simulation of DFA is done. Thank you for watching the video. I hope you guys like it.